Viscoelastic property. You can divide the word into viscous and elastic. Viscous is a rate and time dependent change in stress strain relationship. Viscosity is internal friction of material or resilience of liquid to flow. Elastic is returned to original shape after deforming forces is removed. 4 characteristics for viscoelastic material. Number 1 is creep. Number 2 is hysteresis. Number 3 is time dependent, rate dependent strain behavior. And number 4 is stress relaxation. Creep. Draw the creep. On the x-axis is time, on the y-axis is strain, and draw the curve. And write constant load. Increase deformation of material with time under constant load. For example, cement, intervertebral disc, Ponseti technique, pre-tensioning of ACL graft. And you can take a normal example by putting a plastic bag with weight on the door, which thins up with time. This is creep. Regarding stress relaxation, a constant, the stress, decrease stress over time with a constant strain. So the amount of stress required to keep that strain reduces with the passage of time. Draw the curve. Time is on x-axis, stress is on y-axis. A common example, when you are doing a Ponseti technique or when you are inserting a cementless stem, you punch and then you wait for a while and then you hit it again with the hammer and then wait and then hit it again. Hysteresis, which shows that loading and unloading curves are different and heat is dissipated due to the internal friction. Then is rate dependent strain behavior. The material shows stiffer and stronger at high strain rate than low strain rate. For example, plasticine. When you move faster, it breaks. When you make slow, it elongates. Tendon and ligament show these characteristics. Regarding Young modulus of elasticity, ability to resist deformation in elastic zone. Draw the curve. Ceramic is the strongest, then cobalt chrome, then stainless steel, then titanium, then cortical bone, then PMMA, then polyethylene, then cancellous bone, then tendon ligaments, and then cartilage.